This section is about electric charge. Watch the next clip and note down what it's telling you about electric charge. When you rub a piece of insulating material, like a ruler or a balloon, it can pick up bits of paper or make your hair stand on end. Why?
As I rub the strip with the cloth, negative charges transferred from the cloth to the strip. As there are more negative than positive charges on the strip now, it has a negative charge. The opposite happens when I rub the acetate strip. This time, the negative charges move the other way, from the strip onto the duster. So this time, there are more positive than negative charges left on the acetate strip. It now has a positive charge. The positive and negative charges on these strips appear to stay put, and that's why the effect is called a static charge. And charged objects attract neutral objects like the paper. But it's the rubbing that makes the strips charged in the first place.
But given half a chance, these static charges don't stay static very long.
When a helicopter flies through the air, dust particles in the air bounce off the blades and the body of the aircraft. This causes a build-up of negative charge on the helicopter. The charge can't escape because the helicopter is surrounded by air, an insulator. This build-up of charge could be a problem for Terry here, the winchman. His job is to come down a lifeline to rescue people stranded in places the helicopter can't land. But imagine what would happen if he touched the ground. The charge on the helicopter could escape through his body to the ground, and he'd get a nasty shock. Is there an alternative?
Hi, Terry.
Hello there. Yes, there is an alternative. We attach a static line, which is about 9 feet of wire, sheathed in a plastic coating for about 3/4 of the length. It's attached to the winch hook, and the winchman comes down on the winch hook, holding onto the static line. When he gets close to the vessel, or onto the deck, he just touches the deck or the side of the vessel with the static line, the metal bit of the static line, and that discharges all the static electricity from the aircraft.
Time to see it in action. Terry dangles the static line as he approaches the ground. It touches first, and instantly the charge escapes, so it's safe for him to land.
So we've seen that static charge is built up by rubbing an insulator, but that given the chance, static charge will flow along a conductor. This clip explains what happens.
In insulators, the charges stay put, static charge. But in conductors, the charges can flow freely. If they have a complete circuit, they can keep on flowing. It's called an electric current. But to get the charges moving, they need a push. This is called potential difference. The bigger the push, the bigger the current.
To summarise, static charges can be built up by rubbing when negative electrons are rubbed off, leaving one object positively charged. Static charges exert attracting and repelling forces, and an electric current is the movement of negative charge. There's some more about electric charge in the higher tier science programme.